Today we're going to continue on with section 7.3, and we're just going to be doing more practice with our properties of logs. So, I want you to expand each of these expressions using your properties of logs. Pause the video, do that, unpause when you're ready to check your work. So do both of them. Alright, so the first one here, you could probably do this all in one step. I'm showing it to you in two. I have three things that are multiplied by each other that I'm taking the log of. The base stays the same, so I can separate those into three logs with addition. So I have log base 4 of x plus log base 4 of y to the 6th plus log base 4 of z to the 4th. Now I can just bring the exponents down in front, so my answer then is going to be log base 4 of x plus 6 log base 4 of y plus 4 log base 4 of z. Alright, for the next one. So the square root is around the entire quantity that I'm taking the log of, so I bring that down as a 1/2 in front first. So I have 1/2 log base 7 of the quantity x squared over y cubed. Now I separate this into two separate terms with subtraction. The 1/2 stays with both terms. If you want to factor it out, you could and write parentheses. So for example, I could also write 1/2 times the quantity log base 7 of x squared minus log base 7 of y cubed. So that's okay as well. But we want to recognize the 1/2 goes with both, and then I bring the exponents down in front. So the 2 and the 1/2 cancel, and this becomes log base 7 of x minus 3/2 log base 7 of y. So that's what I would write as my answer. Next one, expand the expression. Pause the video, unpause when you're ready to check your work. Okay, so here I did this all in one step, and there's really nothing else we can do. It's really tempting to do something else with the x squared plus 1, but we can't. So first I separated the fact that I have the natural log of a quotient, so I separated that into two separate logs with subtraction, so we end up with the natural log of x minus, and then the x squared plus 1 had a exponent of 1/2 because of the square root, so that came down in front, so it's 1/2 the natural log of the quantity x squared plus 1. Again, I cannot do anything else with that quantity x squared plus 1. Next two. Here, I want you to condense both of these expressions. So pause the video, condense them, unpause when you're ready to check your work. Again, do both of them. Alright, so the first one here, again, I did this all kind of in one step. I can bring the 2 up on the x and make that x squared, and then because these logs have the same base and there's addition, I can combine them into a single log, multiplying what I'm taking the log of. So it's the natural log of the quantity x squared times the, natural log of x squared times the quantity x plus 1. You can distribute the x squared if you want. Natural log of x cubed plus x squared. So this would be our answer here. Here, for 3 natural log of x plus 2 natural log of y minus 4 natural log of z, bring up the coefficients in front of each natural log as an exponent, and then these are addition, so we multiply them, and then we have subtraction, so that becomes division. Next one, condense the expression again. Pause the video, unpause when you're ready to check your work. Alright, so this one's a little bit tricky maybe, because we have the subtraction twice. So one way to approach this is to just look at these two terms first. So combine those two because they're the first two. And so if I combine those, then I have the natural log of x over x plus 1. And then now that's minus the natural log of x minus 1. Again, the 2 is outside the brackets, so I'm just leaving that there for now. We'll deal with that later. Now because this is subtraction, the x minus 1 is also going to end up on the bottom, and it'll get multiplied by the x plus 1. So I end up with 2 times the natural log of x over x plus 1 times x minus 1. I can multiply those together, and I get 2 natural log of x over x squared minus 1. Now I can bring up the 2 in front. For this problem, I would accept either of these as a correct answer. So either one of those is fine. I would not expect you to multiply out the x squared minus 1 quantity squared. If you did, again, that's not wrong though. But you do not have to by any means. Okay, that's it. So again, just make sure you know these properties of logs and how to use them. Don't worry, I know you're sad that this was only a 5-minute video and you only got to hear my voice for a short time. There will be some longer ones again, I promise you.